Hello students, welcome to another class. So in last class we have read about Ohm's law, and in Ohm's law we have read that V is directly proportional to I. That means the potential difference across the two ends of a conductor is directly proportional to the amount of current flowing through a conductor. So here we have written V is equal to IR, or R is equal to V by I, which is the resistance. R is the resistance of the conductor. Today we will see on what factor this resistance depends. Factor number 1 is length of conductor. Factor number 2, area of cross section of conductor, or we can say, or this is the thickness of conductor. Number 3, temperature, and number 4, material of conductor. Length of conductor is L, area of cross section is A, temperature is T, and there is no symbol of material of conductor. We will discuss one by one how resistance depends on these 4 factors. The resistance is directly proportional to L, that is length of the conductor. How? When the length of the conductor increases, the electron or the electric current has to cover more distance in the or inside the conductor. As a result, the opposition will be more by the conductor. So we can say that resistance will be more. So resistance is directly proportional to length of conductor, means when the length of the conductor increases, resistance increases, and vice versa. This is number 1 equation. Resistance is inversely proportional to A, that means area of cross section of conductor, or that is thickness of conductor. This is number 2. So how this happens? Suppose there is a road and the road is very narrow. You are going by a cycle. As the road is narrow, your speed or the speed of the cycle you have to keep less, because road is narrow, traffic is there, we cannot go by more speed. But when the road will be broad, at that case we can go by higher speed, because we will get lot of empty space to travel. Similarly, suppose this is the thickness of the conductor. How much space electron will get by to travel through this conductor? Will get more space if the thickness will increase. Suppose thickness will increase this. Obviously, the electron will get more space to travel. When electron will get more space to travel, the opposition will be less. Opposition will be less means resistance will be less. So this is number 2. Number 3, R is proportional to temperature, directly proportional to temperature. This is number 3. So when temperature increases, you might have read about thermal expansion. Thermal expansion is the process by which the bodies or the objects, they expand by the application of heat. So when the temperature increases, the conductor gets expanded or expands. When conductor expands, its length increases. As its length increases, obviously the resistance increases. That means when temperature increases, the resistance increases and vice versa. Next is resistance depends on material of conductor. Resistance depends on material of conductor. It means different material are having different resistances to the flow of currents. We are using copper wires in our household wirings. Why not we use iron wires? Because iron is so strong than copper, stronger than copper, long lasting. But why we are using copper and aluminum instead of iron? Because iron has more resistance to the flow of current than copper and aluminum. So different materials will offer different resistances to the flow of electric current. Now look at these two equations, number 1 equation and number 2 equations. Equation number 1 is R is directly proportional to L. So when R is directly proportional to L? Now when A is constant. That means if we keep the area of cross section or thickness constant and increase the length of the conductor, at that case resistance of the conductor will be directly proportional to the length of conductor. And here if we keep the length constant, when L is constant, when we keep the length constant, R is directly proportional to or inversely proportional to 1 by A. That means when area increases, resistance decreases, area decreases, resistance increases. If we combine these two, we can write R proportional to L by A. So at what case we can combine these two? Now when L and A both vary. When both the quantities, length of the conductor as well as area of cross section of the conductor vary, at that case we can combine both the equations 1 and 2 to write these equations. R is directly proportional to L by A. Or we can write R is equal to rho L by A. See this symbol. This symbol is rho. RHO, rho. Some books it is written S also. Instead of rho, it is written S. So rho L by A. Rho is a constant of proportionality. Or we can write rho is equal to AR by L. Rho is equal to AR by L. So what is rho here? Rho is called resistivity or specific resistance. Of material of conductor. It is the resistivity or specific resistance of the material of conductor. So what is the unit? Unit of rho. Here see, area unit is meter square, R unit is ohm, length unit is meter, so unit will be area, unit of row will be ohm into meter. Now can we define the resistivity? Just look here. We have rho is equal to AR by L. Suppose we will take length is 1 meter and area is 1 meter square. That means we will take a conductor of length 1 meter and its area of cross section or thickness will be 1 meter square. So if we put here A instead of A1 instead of L1, we will putting these values, what we can write? Rho is equal to R, because A is 1, R is L is 1. So at what case rho is equal to R? Now when the length of the conductor is 1 meter and the area of cross section is 1 meter square. So can we define the resistivity here? So we can define the resistivity that resistivity is the resistance of conductor of unit length and unit area of a cross section. If we will take the conductor of unit length, that means 1 meter length, and its area of cross section or thickness will be 1 meter square, at that case what is the resistance offered by the conductor? That is equal to the resistivity of the material of conductor. So I hope up to this it is clear to you. Next class we will solve the numerical problems about the resistance and resistivity. Thank you everybody.